Everybody. So I'm going to talk to you today about topic of mine called Sandspiel, and hopefully help you go using WebAssembly, but kind of this topic is going to be a little bit of history of what the project, what some of my goals are for it, and how technology is putting it into what's our WebAssembly, what's using it, and kind of just help her and go from there. That's kind of the format. Um, So, introduce myself fully. My name is Matt. I'm a developer and an artist. And my job title is as a user experience engineer, so essentially engineer with particular forms promoted by hundreds of users. And I work at Google, but none of this talk covers with my work. So that being said, it's the complex Sandspiel, which is a Hall of Fame game that and so Hall of Fame games, if you're not familiar, are this whole genre of games that been around for a while, and there's a lot of different issues of them. But the kind of common is that essentially there is a 3D grid of pixels, and those pixels represent different natural elements, like water and color, sand, and stuff like that. And each different element has maybe a lot of similarity with, and maybe that's each other, maybe that's not in this situation. So I think the point games are really cool for people reasons, and I've been really interested in them since I was a kid. And kind of break down like some of the reasons why people get so engaged. The first one is that they kind of have this property by a lot of other where they simple rules that are actually pretty manual. But when you let those play out and computing and full, there's a lot of complex behavior that never program that produce the game, isn't really predictable, and can be interesting. And this is coming from a place that essentially functions and we're going to head model them. Another thing about these systems that the systems of really low power visual effects, I guess they get rid of our systems. And what that means is that all the detail of the last visual, you kind of can fill that in so it's kind of like a low power simulation and low power visual thing going on. So when you do it, you see much more. So, it needs a lot of space to consider what you see, and often to approach them and explain to you what they're saying is happening. It's much more complex than what that's explaining or even if you know what's in this one, look at the tool after it's really exciting. The other thing is that there's no objective community to it. So it's really just this literally handoff thing where you are looking at objective questions, maybe doing experience to figure out how to work or things necessary or just adding methodology. So kind of interested about the training is a little bit of a different character where it's in player because there's no objective and you're kind of deciding that as you go. So you just kind of really like really creative. My favorite one that I played in all kinds of space was been for a long time, and it's one of the Java tablet. And the feature about it that was really amazing was that it had this upload and download functionality where you could draw your scenario using your phone and actually share that into like this forum thing. Where people could load it and play it and like interact with it and go on it. And people may also think it's really good stuff, including like, little pictures of CPUs and things like that. And the one item that shows that, there was how people come together with this level, there are things to feel volcano. And there's also a volcano. There's always a personal volcano and positive and even better volcano. And there's also things that kind of like design it have fun exploring this or whatever. It's fun, it's kind of like, a little easier. And it's even like there's enough complexity going on with the elements and ways you can design it and it. This is like a new one that uses some of the randomness in the system to like, give you a divination of what you need or whatever. I really like that it's like it's multi-factor, like mobile, it's all about like, learning different things. This is my favorite genre of upload on these games. It is I think I think it's like a prepared program school, and that was really just one of mine. This is a very graphic depiction of what happens to the I don't know if you saw like the lava sucking to the esophagus and like there's like hundreds of kids on so I think this is amazing. Like I could use like front end and one of the things with like Flash Java, which is like the way that we read you build like a good interactive experience of them. And like despite all their flaws, which are like maybe like what we focus on when we about Flash and stuff. Really making it really cool based application. Honestly, like a lot of times things that you don't see so much, it has to be popular on the web. As far as if you get like systems that where it really was like using different software and things like this is in 2005. So that being said, I really just think I'm not cool with idea of what this like fashion or whatever. And I started to program kind of like I think that like humans like love people live together. And they want to stay together. And I'm doing nothing. It's going to be better if it's going to be itself that you're not used to that class together. And so then between I built my children, and I barely knew how to program. I mean, like I was even learning how I was going, like how to use functions and stuff. And so, but that being said, I had a really great time because I was kind of finding out that a lot of the interactions and the components that work in the building, original for myself, were really simple. And it's just a couple of code, this is fun, now this is kind of really good. And everything that this is wrong. And it's interesting to learning to see how simple it is. And so I really was having fun with this project, but as I was implementing more and more elements, I was having like more and more, it was getting harder and harder to write new elements because I wanted to all related to push statements and everything. And okay, with behavior was, I was getting bugs. And for instance, this weird code stuff on the right is an element called this. This is just a bug I have and domesticated and look it up just to get element. And the reason is like performance wasn't great. This is like a 100 pixel square. Maybe let's look at a flash and get more like 200 pixels or 300 pixel square, which is a lot better. And and so I was really excited about this project, but I didn't want to get started with organizing my code, and so maybe even like using multiple files. And so I, moved on to faster. I have to set up these web paths, like multiple JavaScript files, and then I can get faster. And so this is the last thing that I ever made, which was set up these web paths and 10 years faster, and there was never a backup. But then after some time had gone by, we got and everything. I was thinking about something. I got really excited about the idea of a same where instead of like simply just sharing functionality where like basically the level data is just a static function, it would be that you could share like code that would define how elements behave. And so instead of everybody could be designing their own elements, you know, like Susan's cool vine or whatever, and like somebody else made like, you know, Richard's like crazy supercapacitor or something. And all these elements could be like defined in code, and they could be like running in one environment and shared with one another. And so I got really excited about this idea, and I started to kind of like break down what I would take to um, to, to build it. And especially I was thinking about like what would kind of be, what would need to be easy for someone to accessibly like program against interface and build their elements, and how would they be able to be secure so that it's always on one environment and you know, it's not cross scripting or whatever. And so I started to build a prototype after Mira and like with people in mind. And I was like, particularly kind of, and it started doing really well. And I was really happy with kind of the architecture of some of the ways that looked down, and also the kind of performance of it. And so basically, I was being much more intentional about something in engine code, in logic code, and order for the elements to communicate with the engine, or to use the API, like the neighbor, like that, and organize. Then, like, this is also not that kind of sometimes do it, but I started to get really excited about this, and I was starting to enjoy the game, like, look, you know, I want to share with people. And the thing is that if you want to share with people, the real file doesn't really cut, and like, continue to do that. The other stuff, as far as I'm concerned, the best software delivery and using ever, like my one shot. And I wanted, and I could always think as a kid on the web. And so I was like, this needs to be a project that lives on the web, this to be something that is going to take and and so that's my journey to people that help people sandboxing code, efficient execution to those things. And so I and it's not always going to take people like, I was definitely not saying that this is a separate project. I want to use that to make it good. I was definitely like, I would like to build this thing and happy to go and do it like that. And in particular, kind of like the properties of WebAssembly that I thought was interesting. One is that, with employee application JavaScript and that's important. And really, there's, I think there's all the components I can get, I can use. You can always make a bigger pixels or run on their own side. And so, it is something important, particularly because it's just like a lot of CPU people, other ways in that. Second thing is that this opportunity to be running a sandbox manner. So I can take like a block of code that somebody else wrote and run on somebody else's also computer, and that's like possibly secure. Which is like not easy to accomplish in JavaScript. It's like you kind of be a computer or something. And kind of the question mark for me was that it was ready to use, and the teaching was ready, and like the browser support was ready. And something that I found out was that it really was ready to use. Like in particular, browser support was really good. I was kind of expecting like some gross combination of flags and like pieces of flaws or whatever, but really on mobile, like the browser support was really good. Nowadays, maybe got lucky, but this really nice surprise. And also, like in switching support, I was using like, the Rust and Rust engine toolchain, and kind of the both experience and documentation was like really impressive. And as kind of like, really like a web developer kind of person, I felt like very with like, good hospitality as far as things organized as I was expecting, like it's like, I was expecting documentation, kind of giving examples. And so I found these tools that were easy to get started and to kind of like learn as I went. And even in places where maybe there was like still bugs and still getting worked out, all of the development because it was like happening in a manner that I'm used to, and I could engage with really experienced using these tools. Just to like, just to be like, in case you're not familiar with them, these two tools are kind of build and concert with each other, both into like the Rust WebAssembly working group. The first one, Res Impact, is just a workflow tool that can manage some of the boilerplate and run some compilers for you to position your line to go from some Rust code to some WebAssembly code like the browser code you can load it up into a library or into the browser. And so really the surface area of that you put as a developer is basically here's my code and here's where I want the output to go, and it does the rest for you. And then Res and Gen is a really cool tool which basically tries to bridge some of the differences between when you're calling between Rust code and JavaScript code in both directions, functions or component objects or whatever. It tries to basically do mapping so that you don't have to think about maybe the fact that like a Rust function and a JavaScript function thing, but it'll build the bindings for you so that you can write a class in Rust and have it run WebAssembly and then just call it in JavaScript and vice versa. It really makes this kind of there is some complexity there, like that's not an obvious mapping, but they kind of make so you don't have to worry about that. You can just like call functions and stuff and get so I guess that before I should go on, we can give a little demo of what Sandspiel looks like, and then I'll break down how some of these technologies like how we can fit. So this is Sandspiel.com running in the browser. It's just a dev tool here. So basically, this is like a simulation area, and you can select the components from this palette. I just select the place. And we paint it on here. If it's simulated in this area, each one of the hits. I use it as solid, so like there's no big gravity. And like water, liquid, so it falls, but it interacts with ice because it pushes ice will freeze. There's a whole bunch of other elements like water will make plants grow, seed grows into like plants and flowers, and then like the main draw here, like the roller coaster at the theme park, is like all the elements. So so you can like douse everything in oil and dust, which is like really explosive. And then if you draw some flame water like lava, it'll burn, it'll create smoke, and the dust will explode and blow things around. And so this is kind of like how the game works. So I'll come back to this, but basically, the important thing to understand here is that I did not just like write this whole thing. So it's a little bit reductive to like this diagram is a little bit reductive, but essentially like you could say that basically a lot of the UI and the buttons and like the HTML stuff I'm just doing with JavaScript in a normal standard way to do it. And then when it comes to like the simulation and the stuff that's happening in the play area, that's when I'm using Rust simulation. So on the WebAssembly website, they outline like a couple of ways that they foresee Rust and WebAssembly and JavaScript being used together in harmony. And like basically there are three archetypes that they lay out, or like sometimes it's just going to be like a giant C++ app that maybe has been around for a long time. And it gets compiled into one binary, and then you use a little bit of JavaScript just to like connect it to browser APIs. So this is like when you see like Doom or like Windows XP or like I don't know, I'm sure like Photoshop, whatever, like those kind of like heavy applications. There's still some JavaScript at the edges, but you basically got almost everything in C++ that doesn't even really know it's in the browser, maybe. And so that's one way you can combine them. Another way you can combine them, they kind of foresee again, this is like expected user journeys, is that you'll have like pretty much a normal JavaScript app, but some of the module libraries will happen to be implemented in WebAssembly, maybe for performance. And so like maybe it's a like you've got some good examples here. Maybe it's like SoundCloud or something, and you can apply effects to the audio, but and that effect is applied like some like Randy bar module imported from NPM that has included that happens to be included in WebAssembly, but from JavaScript perspective, it's just a library from their repository, and you're mostly thinking of it as JavaScript. And then there's this third configuration, which is the way mine works, which is that you use JavaScript and HTML CSS for your main UI, and so it feels like a normal web application and it kind of obeys the normal web application norms. But you do have like a canvas which has some kind of like data or CPU intensive simulation going on, and that's WebAssembly. So that's how this works. And so whenever when I was building a game, I was kind of thinking of it in terms of everything that needed to be really efficient, and so like run every single frame, or even thousands of times every single frame. That was in Rust and WebAssembly, and additionally, things that needed to be low level and be able to know exactly what bits or where. That's where I could use like Rust and WebAssembly to have control over it. Whereas things where I benefited from either not having a type system and just like having using DOM APIs that maybe are like messy to use from Rust, or things for instance handling like a lot of if we define the actual type of some of these objects is really gross, and so just using JavaScript is easier, and there's not really performance reasons for doing it in Rust. Additionally, like places where you can leverage really mature libraries for doing UI, you don't want to be re-implementing that stuff in Rust right now, and so it's great to do it from JavaScript and use mature library. And so I found this worked really well. Next part of the talk, I kind of want to talk to you about the left side of this diagram, like what some of this code is that is written in Rust and runs in WebAssembly, and how that works, just so you can see. It's pretty simple, and just so you can see kind of get a feel for what it is. And so this is one of my data structures that's pretty important. It is basically the information that is stored for a single cell of my grid. And it's not a lot of data, which kind of is by design. And so basically, it's 4 pieces of information. The first is what species is held in that grid. Species meaning like, is it sand or water or whatever. And there's 2 registers, there's called RA and RB, which are general purpose information used to store state that's used differently by every single species. So not all of them can use it. Sand doesn't need to store any extra state about what kind of sand it is. But for instance, like fire uses it because the fire ember is always like, it burns out over time. And so it uses like RA to hold how hot it is right now. And so that's basically just general purpose data that you use. And clock is not that important. It's used for like symbol keeping to make sure that the element doesn't get simulated multiple times. It's moving around and like breaks in the scan line, but it doesn't really matter. One more thing to note about this data structure is that this is Rust code, and I've got some I don't know what they're called, like decorators or whatever, like extra like annotations on this data structure. And rather than bindgen means take this data structure and export it to be visible to JavaScript. And ref_c means represent this data in memory the way that it would the way it would be represented in C. And so it's worth noting here, just because it seems like really low level detail, but the thing is that this lets you sweat those kind of low level details, even though you're running the browser. And so it's kind of cool that you can add your data structure and then say exactly how you want to and I took advantage of that. This species type, just to extend it out, it's a genome, and I'm just representing these different species as a number. But I've kind of got the same thing here, whereas in bindgen, so I can access this in JavaScript if I want to know what number water is. And also, I have, again, control over exactly who represents the memory. I can say species is a U8, and it fits, and it will, I have that control over it, even though it's only in the browser. So moving up a level, that was kind of the data that I store in 1 pixel. And I've got this grid of pixels and that's kind of like the data structure that I pull the game station. And the way that I run a frame simulation is that I scan through all of the pixels and I run an update function for each one. And there's a different update function I switch based on what the species is. And so I get to a single pixel simulation. I decide which function to run based on what species it is, in this case, sand, and then I run the sand update function. And so the sand update function is the one that behaves like this. You know, it'll try to fall and it'll form these piles and stuff. It looks pretty cool and it's like pretty fun to play with, but just to make the point, like the logic is really simple. It's basically a single if statement, and all it's really doing is reading the value of the grid entry below it. You can do that with like relative coordinates because it uses APIs to access like read and write from its neighbors. And so here it's saying, like, give me the neighbor that's below me, and I'm going to decide if the species is type empty. I will run this code, which basically erases my current location and writes my values to the location below me, so move down. And the other case is that if the species below you is a different type, maybe the sand, maybe stone or something, then it will run this other case, which will try to do the same thing but will look down the diagonal. And so it really is like one if statement, but that's all it takes to like get this kind of same behavior. And I have like 18 other elements, and they all have their own update functions, but they operate under the same principle of, if statements and reading and writing neighbors. So all of that pretty much covers all the code that is written in Rust and runs in WebAssembly. And I export basically this universe class into JavaScript, and JavaScript handles the rest. And so it's got some methods on it. Tick is run one from the simulation. Paint is used from JavaScript to add pixels on the simulation. So it can say add a circle of fire at this location with this radius. And cells is something that's used to get a pointer into WebAssembly memory for rendering. I'll come to that later. I guess I'll come to that right now. Wait, I'll do one more demo quickly. So universe is that class that I was just talking about. And this is just JavaScript REPL over here. And so I can, this is kind of just showing you that when you're in JavaScript and you're interacting with the WebAssembly, the code that's running WebAssembly, it really does feel like you're just doing JavaScript. So I can say, tick, that's one of those methods. I can just call it, and it will run from the simulation. Maybe you can see, but basically, every time I call it, these droplets are moving down a little bit. And then I can also even do what I can call paint. And so this is saying paint some fire in the center of the screen, 20 radius dot. And then it does that. And then I'll come back to this, but there was the other method cells, which gets a pointer into WebAssembly like memory. And I know that like this is JavaScript, and so like what is a pointer? So this is like, it gives me this integer, and in JavaScript, it's like, what do you do with integer to get information? I'll come back to that, but you can, even though like, you can interact with the WebAssembly memory from JavaScript, even if you call it lower levels. So the thing about rendering is that none of that stuff I told you was like, when I said pixels, I was really talking about like entries in an array. Not all that is happening in memory, none of that is visual. And so in order to take that information and put it onto the screen, like it does with the user, I am basically need to get it like into WebGL in order to like run a shader. And so the raw game data that's in WebAssembly is a vector of these cell types, and each one is 4 bytes. But they don't have like red, green, blue, and alpha. They're cell types that are of like species, and then these other values that like, basically they're not colors that you want to see. And so this is what it looks like if you do render the this grid of game data like raw. And it's like, it's not the colors that you expect to see. This is just like the raw game data. And most of it is just green because the species values are all low, and like basically, this is still a raw form of the thing. In order to render it, you have to get it to WebGL and run shader to decide what color you're supposed to do. And so because I have this control over the way that all of my game data is laid out in memory, I'm actually able to do some cool things. And so in this case, because I have this array of like four 8-bit numbers that happens to look exactly like a texture of like that's how bitmaps are stored typically. And so that actually means that WebGL will let me send this information as a texture to a shader. And WebGL is kind of picky about what shape data you can send it. Like it doesn't want you to send it necessarily floats or like other sort of things. Like this is the most well supported data type in WebGL for bitmaps. And so the fact that my game data happens to be a 4-byte bitmap is really convenient because I don't have to do any kind of transformation in order to send it and render it. The cool thing about this is that I'm doing a WebGL code in JavaScript, but I'm still able to package up this texture and send it over to the GPU without copying this information out of WebGL. I can really just kind of like pass it along as a pointer, and it kind of works. And so there's this thing you get from called memory, and it's a buffer. And this is like all of the WebGL linear memory. I'm sorry, all of the WASM linear memory. It's pretty big, but you can like go in here and like find numbers. I don't really know what these numbers mean because this is just raw memory. And you have to, some of them are not 0, but anyway, but that pointer that we got, cells is actually indexed into this thing. I think I might be wrong. I don't understand all this stuff. I think it's indexed into this, and so you can do something where you actually you can form an array, which is just a view into another array, all in JavaScript. But in this case, the first argument is the buffer of all our WebAssembly memory, and the second one is the index into it, and then it's the size. And so when you run this, it didn't copy that data; it just kind of gave you a view into it. And if I go in here, the top ones are 0 because that's like the air at the top of the screen. But if I go to the last values in the list, this will be the sand at the bottom. And so each of these 4 values are like the species, RA, RB, and clock values around our game. And so I think that the 2s are sand. I think sand is 2. And then the other ones are those values. But I know this like got kind of like into the weeds, but this is cool because like I'm not copying our data out of WebAssembly into JavaScript and then from JavaScript to GPU. We're kind of just passing this pointer, and my point here is that you can do some kind of low-level stuff that's interactions between WebAssembly and JavaScript, and like not be paying performance. Like, you can actually be using some of these data structures from both. And so that's what you need to do in order to like render from this raw game state to the colors they actually want the user to see. I'm going to go into kind of like another area of thing that I found out about when I was this game, which is that the Rust compiler has like some levers and some trade-offs you can make in code, which is not something that I was used to with like some other ways I package. Like at least maybe you can minify code on JavaScript, but I kind of was bit by this a little bit because this optimization level, which is when Rust compiles code, you can tell it basically like decreasing numbers from 0 to 3 of how many optimizations to run. And the trade-off there is that no optimizations will compile really fast, the code will be slower, or you can say like optimization level 3, it'll really churn and look for like certain kinds of optimizations and produce a binary which is fast. But there's also these settings which are not optimized necessarily for binary performance, but optimized for the size of the binary. And so we'll make different decisions when it's doing optimization passes about what is a good optimization, because it will try to not do ones that result in a bigger binary. And this, I was using Z for binary size by default in this project because I copied it from some other WebAssembly project. And people assume that if you're writing Rust or web, you need your binary to be really small. And so I was just going along with optimization level Z for most of this project. And then halfway through, I realized that I could switch that from optimized for bundle stuff, for binary size to binary performance. And I actually found that my WASM binary went from 60 kilobytes to 80 kilobytes, which is not a very big increase, but I got like basically a 2x performance increase. And so this is just an anecdote. I'm sure that these, depending on what your code looks like and what your needs are, like Z will be a good trade-off for a lot of people to be trying to handle a small binary to users. But in this case, it was interesting that just the way that LLVM is emitting the WebAssembly here makes such a big difference in performance and not a big difference at all, in my opinion, in the size of the binary. I don't care about it, that's fine. So unfortunately, this cool discovery led to me making a really bad decision, which is that as soon as I got I've been really kind of being very thrifty on performance and really trying to make this game run well. And then when I found all this awesome free performance, I was like, oh, this is great. I'm just gonna double the size of my canvas, make the simulation much bigger, and I can afford this now. It's awesome. And that wasn't awesome because it turns out that people have different phones, and I was and all phones have different CPUs in them with different performance. And so I was developing an iPhone 8, and I was making performance decisions based on what would run at 60 FPS on my phone, with full battery or whatever. And then because it's on the architecture where I have the back end and people are sharing these games, it was kind of hard to shrink my game size later on because then I have all these save files that were big, and people were I didn't want to deal with multiple sizes of save games and stuff like that. And so I felt kind of locked into this size, but now it performs really badly on most people's phones, or at least a lot of people's phones. And so maybe 30 to 20 or 15 minutes. And so this was totally a unforced error. I could have been more cognizant of the landscape of different CPUs and really just use 200 square control instead of 300 square control, and I would have had a much better experience for most of my users. But caution your tail, there's nothing to do. But despite that, people do play with this game. Mostly middle schoolers play with it, and they're not they play with each other and stuff. People tend to mostly use it as a drawing app. Pretty much just cause simulation and block that, and the fact that it's sand, but they're just drop little blobs and stuff. And I think that's awesome. This is really gratifying. This is really play with it. But people have uploaded some stuff that surprised me. Both in negative ways, but more focused on ways they expect in the positive. So there's been one is that people somehow have actually scripted methods to automatically push bitmaps into this format, and so people have uploaded some art and stuff, and punching this card palette, and you can actually load these and then press play, and on the screen, that's lava and oil, so it's to burn and stuff. So it's kind of cool. It's really you can see these play. We don't really love them in the bottom right. I put that little video in Nintendo. And this was the only one of these images that really had really into the game for a long time, and so everybody used to there's a kind of a forking culture and this one would draw a message on it, stuff a lot. There's a lot of versions of the oh yeah, but another thing that surprised me about some of the data that I uploaded was this image. And this submission is interesting because I don't have a complete element in the game. And this element that is like submitted and that's full screen doesn't, you can't produce it like when you do normal. And so basically the way this works is that this has not that when I create a Pokemon, which is missing no. Missing no, if you're not aware, is a Pokemon that you can capture in like any of the Pokemon games, but it does not like potential features by developers. Essentially, it is like you, it is like an out of bounds index of a Pokemon you caught, but then you'll it's Pokemon. This is missing no like, in the game. And it occurs when much like I have these like species indexes, Sigma, whatever. Pokemon is a similar thing. They have underlying data structures that have indexes that correspond to different species Pokemon, and those are indexed into memory to get information about the Pokemon, like what does it look like and what its stats are and everything. And if you are able to find a Pokemon that has through glitches or whatever that has an index that points to some other memory, they'll just interpret that memory as a Pokemon and they'll have weird properties and that's what it's yellow. And so similarly, like the felt element, that's what people call it in the game, is somebody uploading a number that is outside of this range, and then all of my code basically assuming nothing possible and like just trying, and then whatever the figure happens otherwise. And so in this case, there's a bunch of switch cases, and it basically falls out of all of them into the default case. But then there's some code, there's some behavior which is outputting for every element, and so it only has the behaviors that every element has. For instance, it is like going around by wind, but it doesn't have any of the same behaviors until it. This is like a total surprise to me. Really exciting. Oh, okay, it's so cool. Makes me really happy. It's actually a cool element. Like it's fun because everything else you can interact with, everything else that reacts to the game is kind of animable, and so this is like an interesting kind of movable but sticks around element. I guess that's an anecdote. You should totally play the game if you want to play with it. That's online if you feel and I've got a blog post that is pretty in depth. I've got a lot of things here. That's on making Sandspiel. And source code is online as well on GitHub. And thanks for listening.
Awesome. I happen to know some Super Bowl and one Super Bowl and something.
Okay, so since Super Bowl is an element, okay, so it'll be different. No, yeah, that is what it is. So, like I said, like falling sand games are kind of this whole genre, and so there's a lot of like among the falling sand games, typically all get other people, but they have like there tends to be certain tropes of the genre. So, like, almost every game has elements. Super Bowl is another one that isn't in all games, but popular and so someone do it. And I think what Super Bowl is that it is an element that's kind of unique because it has and it actually like, store its EX and Y, and then it puts a wall with that top and everything. And so I did that kind of maps well to two registers. I only have two registers in information I can support. The EX and Y is pretty much that's the most information I can hold. And so we experiment with elements that use RA, RB as EX and Y. And the way that we and then I made different parts like kind of felt that that was fun. And the way that the closest thing that maybe to the game is that it's rocket, which it touches a ball, it touches an element, and then since the element included like salvage like that. And so it has in common the super ball that has the FTD wall, but it doesn't have the wall. And so it would be fun to try to build that into it. Top five elements because mobile, but there's not given space for them in my palette. There's one other skill and stuff. And so that was my second one. I think that because when you're a browser, web browser is good, but you can use the web browser API without going through JavaScript anyway. And then I've heard that I've heard like a promising thing that to use web API especially directly from WebAssembly. But I didn't want to mess with that in this project because I think it's a pretty simple, like there's eventually a project and so I didn't comment to it. The rendering here is very fast. It's not that yet. I have to comment to
It actually does support raw WPL. Except then what happens is it's really WPL. And then also and also push functions, automatically mapping the WebAssembly so there's a lot of work being done with exactly now that people are so attached to people with things like, are you concerned that you change the version of the compiler you're using or compiler flag or something? Compiler or is it just that you want to that?
There's a story. Yes, I am concerned. I am concerned. Okay. Good question. So the truth of it is probably good because that's actually it's a good point so like the rendering is like it's basically but there's this basically a description of the computer so each of these different numbers and there's one of them which is number 10 this one um, there's no like connection between the numbers and if this sync element of knowledge that I have that I use and never use the computer that's what it's but also it's just which is going to fall off the bottom of this pushing in and then this is just an initial initialization. The thing that's in jeopardy that I actually lost as a developer is that the fact that it was blown by sound, or sorry, blown around by wind. I originally, like every single element was blown by wind, using this wall and doing it. So here I have a switch thing, and now you know what's interesting about what code Rust commits when you switch and do them, and like basically you put in default parameters. One of the values of arrays when you list it is default. Well, it's kind of like to preserve the elements that you like. Later on, afterwards, and and Rust kept not getting that default case because it was like, oh, this is going to be lost with you have any switches, so it only ever hit the default case. So why would I use the default case? But that's kind of what we did. And I guess Rust is a little bit more you switch on everyone with a default, it's still going to have, like, just like, things are good. Good day experience. And so I had to, in order to convince the compiler to make the default case, I had to make sure that the neurons don't push something out, different elements. Because there's only that derivative, not only, it is like, it did kind of a little bit backwards. It is weird having different changes and mostly I don't care. There aren't always like there are, there's like a cool group that you can go. They use it almost all the time. Two different ways like that. I'll get much before. Good question. I guess I'm going to try to do it. I guess that was like my plan was to get there, and I got excited along the way. My goal was to make it. My first immediate goal along the way was to make it. I only like 10 minutes going to do that. And even if it's often how we're going to do it, but at least like the way that we were trying to do. And then I have fun of looking at it like that. And then feeling more about I still want to get back to that goal. I think we just do a different concept. And a few issues that can be solved and different. One is to have a switching and using environment that and where being able to help people functions and have them run with one those things. I guess that's the way to do it. Support like we can have something really and formula, but it's just like a switching. And the other problem, which is the outside, is that it's a lot of elements reference programming, and there's a bigger, like oil, specific reference and in the world, so there's a lot of different ways you could have like, elements that people who have never, like, you never have each other that have have a single one way is you can help with development and creating stuff, but that's more creative than I want to do in this relation. Not really physical, maybe this relation of like physical and something that I'm so excited about that, but I need to go. Yeah, so the most sensitive, like when I said that the browser support, like really good, they're really like better than WebGL because WebGL is really like across different phones, on different sites, and it's not like they're like fault. It's not like it's just bad. It's because WebGL is really good to the audio and the graphics stuff, and so there's not like the WebGL stack is becoming very different. And so I have the best is what can be done is how to take these directly to that you know, I would definitely do it.
So, Eric, welcome back. Thank you. So we take three. Done. 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 Our hosts are breaking up to us stay there till 9 o'clock. So around by questions. Also take it yes, at that window, raise the bottom.
No.
Yes, let's see. Next meetups. Kind of rare, but we have the next 3 hosts already picked out.
Wow.
Figured out. So we're so there's nothing to read me that if you're speaking at Sandspiel. And yeah, I'll post the next copy. And thanks again for all of you. And it was fun.